Welcome back. Welcome to this section on functional programming. Now, if you ask me what is the biggest difference between functional programming and object-oriented programming, then the thing which stands out is that in functional programming, functions are first-class citizens. What do I mean by first-class citizen? Let's look at an example in here, right? So, student is a object. The object, I am able to store it in a variable. I am able to invoke methods on the variable, and we can pass the object as data to a method. Now, think about a function or a method. Will I be able to pass function as the parameter to a method? Will I be able to get function as a return value from a method? Can I assign a function to a variable? Nope. Until now, in whatever we have discussed, we store objects in a variable, we send objects as parameters, and we get objects as return values. But for functions, we will not be able to do that. And that's where functional programming comes in. Functional programming comes in and says, try and give first class status to functions. Now, you might be asking, how do we do that? That's basically what we would try and do in the next few steps. Trying to create variables with functions, trying to pass functions to functions, and having return values as functions brings in a complete different thought process. And as a beginner, it might be a little difficult and tricky to understand all this. So what I'll do is we'll keep it very simple. We'll try and go one step at a time with very simple examples and try and introduce you to the wide range of concepts that are related to functional programming. Welcome to this section. I'll see you in the next step. Until then, bye-bye. Welcome back. Let's now create a new project for functional programming. I'll say new project, Java project. I'll call this functional programming. When you click finish, a new project would be created, and in the source, I can create our first class. So let's create a very simple class, and I would put it in the package com in 28 minutes, functional programming. And I would call this class as functional programming runner. There are a wide range of things that we would be discussing, so I don't really have a better name than that. So let's add in a main method and click finish. In the previous video, we said functional programming is all about giving first class status to functions. It's kind of a cheesy definition, but let's see what it all means in this specific step. We'll try and create a very simple example, not using functional programming. That's basically using procedural or object-oriented programming. And we will see how it can be implemented in functional programming. Let's create a very simple list, right? So list of string, I'll say list is equal to, we did that many times during the collections thing, right? So list of apple, banana, cat, and dog, right? Typically, if I would want to, there are imports. Let's do the imports as well. Typically, when we would want to loop this, we would probably use a normal loop, right? List, for string in the list. If I want to print out, I would say sys out, string, right? So if I want to loop through and print all the values, this is what I would typically do. Cool, right? So now apple, banana, cat, on dog. That's cool. So I can right click, refactor, and extract method, and I'll call this print basic, right? This is how we would print any list, right? However, with functional programming, it brings in another approach. I'll write in some very simple piece of code. You might not be able to understand that completely in this specific step, but over the period of next few steps, we'll try and understand and break down the code that I would write. Now, I'll create a very simple static method. I'll copy this basic. So what we want to do is print with functional programming. I'll call this print with FP. And in functional programming, the way you can do the same thing is by saying list dot stream. So I'm taking all these elements in the list and I'm converting into a stream of values. So this becomes a stream of values. So first apple would come, then banana, then cat and dog. So list dot stream dot for each. What do I want to do with for each? You can see what action you want to do. Action is nothing but method, right? What action do I want to do? What I want to do is I would want to take each of the elements. So I would want to take each of the elements and I would want to call system.out.println on these elements. Now, focus on this syntax. So after for each, after the parenthesis, I'm pressing enter and I'm pressing an enter after here as well, so that you can actually focus on the syntax. So what I'm saying here is list.stream.for each, open parenthesis, within the parenthesis we are saying element hyphen greater than. This is a specific syntax. This is called a Lambda expression. We will discuss that a little later. What we are saying is for each element in this list, do a system.out.println. This is nothing but logic, right? This is method code. So I'm saying for each element in this stream list, do a system.out.println of element. Now, what I'll do here is instead of print basics, I'll say print with FP. Now, let's see what would happen. Aha, apple, banana, cat and dog, right? Instead of looping and telling what to do with each string, what we are doing is we are converting this into a stream and we are calling for each in it and we are passing what to do with each element. Interesting approach, isn't it? Another interesting thing in here is the fact that what are we sending to for each? Is this data? Nope, this is not data. This is action. We are sending the code. We are sending for each element execute this. We are sending a function code to for each. So I said in the last video, function as first class citizen, and this is the first step to it. We are actually sending a function to execute on each of the element in the stream, and we saw it being executed and printed in. I can even change the logic in here. So I can say for each element, just say element hyphen element. What would happen? Aha, element apple, banana, cat, dog. So let's put a space here to make it even more beautiful. Cool, right? So not a lot that we have done in this specific step, but we have introduced you to an important syntax of something called a lambda expression. Don't worry about it. The important thing is we are able to pass in a function as a parameter to another function and loop around it. That's the first important concept about functional programming that we have learned. This is just the stepping stone. There are a lot of things you need to learn about functional programming, and we will continue the journey in the next step. Until then, bye-bye. In the previous step, we created a list of string and printed it with functional programming. Let's now discuss about an exercise. What we want to do is create a list of numbers and we would want to loop around it and print it using functional programming. Try and do it in the command prompt. So try and do it in JShell. You can pause the video in here, go to JShell and try and implement that. Okay, I'm launching up JShell right now, and we want to create a list of integers, right? So integer and list is equal to new. Oops, let's use list dot of and create a list, right? So let's say I create a list of numbers. Now, I would want to be able to loop this list, and I would want to be able to print all the values using functional programming. How do I do that? List dot stream dot, what do I need to do? List dot stream dot for each. What do I want to do with each of them? I press enter so that we have clarity on what we are doing in here. For each of the element in here, what do we want to do? Hyphen greater than is part of the syntax of a Lambda expression. System.out.println element. So we want to print every element that is present in there, right? I'm pressing enter again, closing the bracket and pressing enter. What is happening? 1, 4, 7, 9. Isn't that cool? You can see that this is very simple line of code without using a loop or anything. I'm able to execute. The way it works is each element is streamed, and for each of the element, this line of code is executed. And so first system.out.println 1, system.out.println 4, 7, and 9. Awesome, isn't it? Let's end this step in here, and in the next step, let's move on to a little bit of more complex stuff around functional programming. Until then, bye-bye. Welcome back. In the previous step, we discussed the for each and passed some code to print the element out. In this step, what we want to do is we would want to add logic. In the previous step, we were actually printing everything, right? So I would want to filter and I would want to print only certain elements. So I'll change banana to bat. And what I want to do is I would only want to print those things which end with AT. How do I do it typically? Right, so print basic, I'll call this print basic with filtering. Right, so print basic with filtering. How do I do that? Typically, if string dot ends with AT, so if string dot ends with AT, then print it. Right, so this is how we would do this typically. Now I can call this print basic with filtering in here. Instead of print with FP, I'm changing it to basic with filtering. And what's happening? Bat and cat. Only bat and cat are being printed. That's cool, right? So bat and cat. Awesome. How do we do the same thing with functional programming? Before doing a for each, we want to do something. Let's copy this. Print with FP with filtering. Let's call it that way. I just wanted to leave the code in here so that it's there for future reference for you. Now, over here, what we are doing is to the for each, we are passing in a specific piece of code, right? We are saying for each element, do this. That's basically what we are telling in here. Now, what we want to do here is we would want to only pick up those things which end with AT. The way you can do that is by adding something called filtering. So I can say filtering logic. So for filter, only allow these things to go in. Which are the things that I would want to allow to go in? Allow these elements which have ends with as AT. So what are we doing in here? We are saying filter. Oops, let's make it even more clearer so that you can see what's happening in here. So what we are doing is here filter open parenthesis element hyphen greater than, that's lambda expression symbol, element dot ends with AT. So we are saying filter these, only take those things which satisfy these conditions. So we are sending the logic again. We are sending the logic to the filter method saying if this logic is true, then go and do this. Otherwise, don't do anything. Let's run this right now. Oops, I did not change the call. So let's do print with FP with filtering. Let's run this. Aha, element bat and element cat. Isn't that cool? So you can see what's happening in here, right? So instead of looping around, we are talking in different terms in here. With functional programming, we are not trying to loop around and do a lot of stuff. All that we are trying to do is we are telling what should you do with each element. We are saying here, first is filter that element. So filter, what should be the filtering logic be? It should ends with 80. That's the filtering logic. Okay, what if it's ending with 80? Okay, for each one of them, take it and print the element out. Let's do a couple of exercises. Over here, what we are doing is we are printing all the numbers, right? So we wrote list.stream.forEach, we are printing all the numbers. Try and filter only the odd numbers out. So that's the first exercise. The second exercise is try and filter out only the even numbers. Output of the first exercise would be 1, 7, 9. The output of the second exercise would be just 4. So you can pause the video in here and try those things as an exercise. Now let's go ahead and do that. How do we do that? List.stream.forEach. Nope. Before for each, what do we need to do? We need to do a filter, right? So let's do a filter. So what do we need to filter? All elements. Element. Let's start with printing the odd numbers. Element mod 2 is equal to 1. So if it's is equal to 1, then it means it's a odd number. So I'll put a parenthesis in here. What is happening in here? It's actually creating a filter directly. To prevent that from happening, what I'll do is I'll put filter and say dot, so that I'm telling JShell, okay, there is more code I'm writing. Now I can say for each and write in the code that I would want to execute, right? So what do I want to execute? What do I would want to do with each of the elements? I would want to print it, right? System.out.println element. You are printing 1, 7, 9. So if I write the same code on single line, it would look like this. List.stream.filter, and to the filter I'm setting each element, filter using this logic. Element mod 2 is equal to 1 dot for each element hyphen system.out.println element. Make sure that you get the parentheses right, and then it would work out fine. So it's basically very simple. So to the filter within parentheses, I am saying the logic to filter. So it's element mod 2 is equal to 1. And for each of these, I would want to say element system.out.println element. Isn't this cool? I mean, without doing a loop, we are actually trying to implement a lot of logic. Isn't that awesome? Let's move back. What do we want to do? We want to print the even numbers, right? 0. That's it. It prints the even numbers. Functional programming is a very tricky thing to understand, but it's a lot of fun. The initial steps might seem a little difficult, but I'm sure if you spend a little bit of effort, you'll start loving functional programming a lot. I'll see you in the next step. Until then, bye-bye. Welcome back. I'm sure you're having a lot of fun with functional programming. And in this example, which is example 3, what we would want to do is find the sum of a list of numbers using functional programming. How do we do that? Let's get started. So I'll create a new class. I'll call this FP number runner. And I'll create a main method and say finish. Right, so it's very simple. What we want to do is we would want to create a basic list, right? So we have created a number of lists before, so list of Oops, not number, I'll say integer. Numbers is equal to new list, or I can directly initialize it in here. List of, let's take a set of numbers 468, 13, 3, 15, and import java.util.list. Make sure it's java.util.list. Now, what I would want to do is numbers dot stream dot for each system.out.println, right? This is what we did earlier. Element for each element. What do we want to do? System.out.println of element. Cool, right? So this is what we did earlier. And what is the output of this? Is we print all the numbers. And we tried filtering this list in the previous example. And that's cool, right? So now we are able to print the list. What we want to do in here is we would want to be able to calculate the sum of all the numbers. Typically, how do we do the sum of all numbers? It's very simple. For number in numbers, take the int number in numbers, and sum plus is equal to number. You might be asking, where is the sum? Okay, let's create it. Int sum is equal to 0. Now we have system sysout sum. This is the usual logic that we write. So if I do this, what would happen? The sum is printed in here, 49, right? So let's comment this piece of code out so that it does not disturb us. When you run the program again, 49. Cool, right? So this is 49, which is the sum of everything. Now, let's extract this to a function so that it doesn't disturb us anymore. Right click, refactor, extract method, normal sum. Let's go. And I'll now try and do it in the functional programming way. How do we do it in the functional programming way? We would start with the same way, right? So numbers.stream, what we want to do is we would want to add all these elements up. So we have 1, 2, 3, 4, 5, and 6. What we want to do is we would want to reduce these 6 elements to one element. How do we want to reduce it? That's the important part, right? So what we want to do is take each one, each pair at a time, and add them up. So let's start with 0. 0 plus 4 is 4. 4 plus 6 is 10. 4 plus 6 plus 8 is 18, and so on and so forth. How can I reduce a pair to 1? So how can I do that? That's where another function called reduce comes into picture. To the reduce function, I can tell the initial value. The starting value is 0. So I would want to start with 0, and for each pair of numbers, number 1, comma number 2, what do we want to do? We would want to add them up. Number 1 plus number 2. And we would want to take this, and this would be the sum, right? Int sum is equal to this. Let's remove this execution in here. Let's make this really clear. So we are calling the reduce method with 2 parameters, right? The first parameter is 0. The second parameter is the function definition. The function definition is for every 2 pairs of numbers, what you would need to do is number 1 plus number 2. Now when I run this, what would be the sum? 49, exactly the same as before. The interesting part over here is these parentheses, right? So you can see parentheses in here. When you have only one element, so let's uncomment this. When you have only one parameter to a method, then you don't really need a parenthesis around it. So this is okay, this is fine, but you don't really need it. But when you have 2 parameters, here we have 2 parameters, number 1, number 2. So when you have 2 parameters, you definitely need to have parentheses. What we are doing in here is we are specifying what is the starting value and how each of the pairs from here on should be treated. We have to reduce them, right? So we have to reduce all this set of values to one value. And how can you reduce pair by pair to a lower value? The way we can reduce it by adding them up. So numbers.stream.reduce, starting value is 0, and from then on print number1 dot number2. So from then on keep adding each pair. So it would start with 0 and 4 as the first pair. So 0 comma 4 would be added in, and that would be added to 6, and the next pair would be the sum of those and 8, and then the next pair would be the sum of those up to 8 and 13, and so on and so forth. The exercise for you for this specific step is to find the sum of only the odd numbers in this specific list. So you can try and update the code in here to find out the sum of only the odd numbers in this list. I'll see you in the next video where we will be solving that exercise. Until then, bye-bye. Welcome back. The exercise that we talked about in the previous video was to print only the sum of odd numbers. How do I do that? Before the reduce, I can call filter, right? Simple. Filter number. For every number, only allow the number to go through if it's odd. So only allow the number to go through if number mod 2 is equal to 1. Now let's run this. The last number is the sum, 31. So it's only summing 13 plus 3 is 16 plus 15 is 31, right? So if I comment this out, I'd be able to see 31 being printed. Cool, isn't it? So what we are doing in here, we are streaming numbers, we are filtering those which are odd numbers by calling the filter function and sending the logic to it, and then we are summing them up by using the reduce. Now spend some time comparing this piece of code with this piece of code. I'll also extract this to a method so that we can compare easily. So I'll say fp sum. So we have normal sum and fp sum right next to each other. I'll remove the filter as well because we can then do a apple to apple comparison code which is doing exactly the same thing, right? So I can reduce the code down so that you can actually read it much more easily. This is much more readable format, right? So number.stream.reduce and do the addition, and over here I don't even need a local variable, right? So I can say refactor inline, so it will replace and directly return the numbers.stream. So what is the difference between these two methods? Think about it. Spend some time thinking about whether you'd like to write this kind of code or whether you'd like to have this kind of code. How is functional programming different, right? One of the major difference that you can see in here is the value of the sum variable, right? So the value of the sum variable is initially 0, and each time you loop around the number, the sum gets incremented. So the value of sum is changing as you keep looping around this loop. This is called mutations. So the value of sum is changing. Your program has mutations. Think about another thing, right? Here we are saying exactly how to do the sum. So we are saying, okay, initialize it to 0. We are saying loop around all the numbers, take each one and add it out, and then return that value back. With functional programming, we are not worrying about all that. We are saying, okay, take a stream of numbers and for each one of them, add them up. So what should I do with every pair of numbers? Add them up. That's the only thing I'm telling it. I'm not worrying about local variable. I'm not worrying about how to loop. So I'm just saying what to do, add them up. Here, we are not just saying what to do, but we are also saying how to do it. Create a local variable, add each number to it, store it into a temporary variable, and finally return the value back. Two important differences between functional programming and typical procedural programming. In functional programming, we avoid mutation of variables. So we don't really try to have variables whose values are changing. The second thing is we focus on telling what to do. So every pair of numbers, add them up. How many ever numbers are there? Keep adding them up. That's what to do. We don't worry about how to do it. Here we are trying to tell how to do it. Take each number from the array, then add it to the previous calculated value of the sum, and at the end of the entire method return the sum back. You don't need to do that with a functional programming. The idea behind this step was to compare the functional programming approach with the typical procedural approach that we follow. I'll see you in the next step. Until then, bye-bye. Welcome back. Until now, we learned that functional programming is all about giving first class status to functions. One of the parts of giving first class status to functions is allowing them to be passed as parameters to another method. We got our functional programming journey started with that in the previous steps, and we also talked about the fact that with functional programming we would not have any mutation of state, and we said functional programming focuses on telling what and not how to do it. In this video, let's look at some of the basic terminology that is typically used with functional programming. The first thing is this thing called Lambda expression. So whatever you are seeing in here is what is typically called a Lambda expression. A Lambda expression is nothing but a shortcut method. So this is a shortcut form of creating a method which accepts two parameters and returns the sum of them back. This is called a Lambda expression. And in a Lambda expression, actually you can have multiple lines of code as well. So let's say I would want to see what's happening behind the screens of that. So I can put this in parentheses. And over here, once I start putting up, then I would need to do an explicit return. I'll also add in a sysout. So within the parentheses, you can write any specific blocks of code. So I can say system.out.println number1 plus number 2. So what we are doing in here is we are creating a method. So this entire thing is what is called a Lambda expression. In the Lambda expression, we create method definition in a shortcut format. A Lambda expression has parameters. These are all the parameters. This is the body. And what happens when we execute it? You can see that first 0 and 4 are passed to this method. The sum is 4. Then 4 and 6 are passed. 4 plus 6 is 10. 10 and 8 are passed to this method. 10 plus 8 is 18. And 18 plus 13, 31, and so on and so forth until we get to 49. Right? That's how this execution is happening. This might be a better way to format that specific method. You can have Lambda expressions without the parentheses as well, but only if the logic is very simple. You cannot have multiple lines. You have to have only one line, and when you have only one line, you don't need a return. Cool. So this is basically return number 1 plus number 2, and I can remove the semicolon also. The next thing that we were using is streams. Stream is just a source of objects. In this case, it's a stream of numbers. It could be stream of strings. It can be stream of objects of a specific class, or whatever stream it might be. And typically, when we talk about streams, there are two kinds of operations that we typically do. These operations are called intermediate operations as well as terminal operations. In our first example, what we did was try to filter it. So what we are doing in here is we are filtering elements. This is an intermediate operation. An intermediate operation takes a stream of elements, either reduce the number of things in the stream, or it might map one element to a different element of some other kind. But the result of an intermediate operation is another stream. So after filtering, you still have another stream of elements. Terminal operations are those where we consume the element. So for each, what are we doing with the element? We are printing it out to the console. Reduce is another terminal operation. What are we doing? We are reducing it to one result. So we are taking a stream as an input and we are reducing it to one result. We are consuming the whole thing and giving a simple result back. That's called a terminal operation. So the difference between an intermediate operation is the output of an intermediate operation is typically another stream. And the output of a terminal operation is either to consume the entire stream or to return one result back. Examples of operations that are intermediate operations are filter. We'll talk later about sort, distinct, and wide variety of such stuff. The terminal operations are, for example, finding out the minimum element in a particular stream, finding out the max element in a specific stream, finding out the sum of a specific stream, or trying to take each element and trying to do something with it using a for each. These are all called the terminal operations. In this video, we talked about the basic terminology around functional programming. We understood what a Lambda expression is. It is a shortcut for creating a function and it can have multiple lines of code, and when there is just one line of code, we don't really need to do a return. That's what we learned about Lambda expressions. After that, we discussed a little bit about the streams. We talked about intermediate operations of the stream, and also we talked about the terminal operations regarding a stream. Until the next step, bye-bye. Welcome back. In this video, let's look at some of the intermediate operations that can be performed on streams. There are a wide variety of intermediate operations like sorting, like finding the distinct elements, and also trying to map one element to another element. Let's start with creating a simple list of integer as usual. So list of integer numbers is equal to list of, let's have a set of numbers 3, 5, 8, and let's say 213, 4, 45, and let's say 4 and 7. This is a list of 7 numbers. What I would want to do first is I would want to sort and print these values up. How do I do that? Sorting. What is the result of sorting this? It's another list of values, right? So when I sort a stream, you would get another stream back. So it's an intermediate operation. So how do I do that? Numbers dot stream dot, what do we want to do? We want to do sorted. So stream dot sorted dot for each, what do we want to do? For each element, e system dot out dot println e. So I've reduced element to e now. So what happens? It's sorting and printing the values out, right? So this is how you do sortings in a stream. So in this stream, there is a method called sorted, which would take all the numbers, sort them, and then we are sending them to for each to print it. Now let's create another set of numbers. In here, I would want to create a few duplicates just to make sure that our code is working, right? So 3, I'll insert a few duplicates in here. So we have 2 duplicates in the list, right? 3 and 5. And we want to find out the distinct elements in this specific list. How do we do that? The function is distinct. So you can see 3, 5, 213, 45, and 7. And the important thing is it's also printed in the order in which they are present in the list. Now you can also combine a few intermediate operations. So after distinct, if you want to do a sorted, you can do that as well. So distinct dot sorted. Now all the distinct values are sorted. The thing is, on a stream, on any stream, you can execute any number of intermediate operations. Obviously, they can only be one terminal operation, right? So at the end, the stream has to be consumed or reduced to one result or reduced to a list or something of that kind. Once you have reduced it to a list, that's the end result. So a stream can have multiple intermediate operations. The last intermediate operation that we will be looking at in this specific step is something called map. Let's say I would want to take these elements from the list, find the distinct ones, and find the square of the number and print them. So I don't want to print the numbers as they are, but I would want to print the squares of each of these distinct numbers. So I can say distinct. Once I have the distinct, I would want to square the numbers up. How do I do that? I would need to map from each element. So each element, what do I want to do? I would want to do E star E. So I'm mapping each element to the square of that particular element. Let's see what would happen now. You can see that now the squares of the elements are being printed. If we actually wanted to do it, then we could have done distinct, sorted, and then do the squares of the numbers as well. In this video, we are talking about a wide variety of intermediate operations that can be performed on the streams. We started with looking at distinct, sorted, and now we are looking at the map operation. I will see you in the next video where we'll be discussing about the exercises. Until then, bye-bye. Welcome back. In this video, let's look at a variety of exercises related to the intermediate operations of a stream. The first exercise what we want to do is print the squares of first 10 integers. A clue in here. The clue is integer stream dot range of 1 to 10. So this is something which you can use to generate a stream with the first 9 numbers. So you can try and explore this, and I would want to print the squares of first 10 numbers. There is a small bug in this piece. You can find that out and print the squares of first 10 numbers. The second exercise is to take a stream like this, take a stream of strings and try and map them to lowercase. So I would want to map these to lowercase and I would want to print them out. The third exercise is to take these elements, to take the same string and print the length of each of these elements. And the calculation of the length, I would want it to be done using a map operation. These are the 3 exercises. You can pause the video in here and give it a try. Okay, let's move on to the solutions now. The first problem is to print squares of first 10 numbers, right? So to understand in stream.range of 1 to 10, I'll try and print them first as they are. So I'll do for each p system.out.println p. It's printing up to 9. So that's one of the first things that you need to learn about range. The thing is, the outer bound here is exclusive, so it's not included. So if I want to print from 1 to 10, I can say 1 to 11. So that's number 1. Now, once I have this, how can I print the squares? The way I can do that is by saying map each of these elements to E star E, right? I can map it to E star E and then for each do P system.out.println P. Cool. Now we are printing the squares of first 10. You can try to print double these numbers, cubes of these numbers and all that. And you can see how easy it is becoming to do things like this with functional programming. You don't need loop, you don't need anything. You just say how to map one element and all the magic happens behind the screens with streams. The second exercise was to have a list like this, right? So I would want to have a stream of this, and what I would want to do, map all of these to lowercase. How can I map these to lowercase? I'll say map s to s dot lowercase and then for each p system.out.println p. Oops, the lowercase. Actually, the function name is too lowercase. Cool. Now you have apple and bat. So from this list, we are printing apple and bat. That's cool. Now the last exercise was to print the length of each element, right? So over here, what we want to do now is instead of lowercase, what we wanted to do is s dot length. Cool. 533. That's awesome, right? So what we are looking at is a few examples of intermediate operations. The result of all the intermediate operations is another stream. So if I have a stream of 10 elements, after the intermediate operation, there might be more elements. Yes, there might be more elements also. There might be more elements, or there might be less elements, or you map it to some other elements. At the end of an intermediate operation, you will have another stream. I'll see you in the next video. We would be talking about terminal operations. Until then, bye-bye. This video is part of a Java course with more than 250 steps helping you become an expert on Java. You can find the complete course details in the description of the video. Along with it, you can also find the details of a free PDF with 200 pages of awesome code examples in 28 minutes, creating great programmers.